So here molality small m is equal to number of moles of solute per 1000 gram of solute. So how many number of moles of solute are there in the 1000 gram of solvent? That is the molality of that compound, right? Molality is used in the physical chemical calculation of boiling point elevation and freezing point depression. For a dilute aqueous solution, M and capital M will be quite close. In order to interconvert M and capital M, we need to know percent volume of weight by weight. Okay. For dilute solution, M, capital M will be quite close. In order to interconvert M and capital M, we need to know percent volume or weight by weight. Now mole fraction. The fraction of total number of moles present represented by compound in the question. So mole fraction we want to calculate here. So solution, for example, in a solution containing N1 moles of compound 1 and N2 moles of compound 2, N3 moles of compound 3, mole fraction of compound 2 is, so we have compound with moles N1, N2 and N3 and mole fraction of compound we want to calculate. So what we do? We calculate simple proportion N2 divided by N1 plus N2 plus N3. So mole fraction of compound is important in physical chemical calculation, but it is not often used in biochemistry. Okay, so that was mole fraction. Calculate the molality of a concentrated stock of HCl solution described in a problem. Okay, so previously we have described one problem. Next, calculate the mole fraction of the HCl in a solution. So solution has a 28% weight by weight HCl, that is 28 gram HCl per 100 gram total, and 28 gram HCl with 72 grams of water. So we say that our HCl is not 100% pure, it is 28% pure, that is means 28% weight by weight. Okay, so how much water it has? So it has 28 grams of HCl and 72 grams of water. So if you do calculation like this, 28 gram HCl divided by 72 gram of water, multiply by 1000. So in the 1000 gram of water, how much HCl do you expect? It is 388.9 grams of HCl divided by 1000 gram of water. So this we have here. So for 1000 gram water we have calculated how much HCl will be there. 388.9 gram of HCl. Now we know formula weight of weight in a grams divided by molecular weight is equal to moles. So we want to calculate how many moles are present in a 1000 gram of water. So 388.9 divided by 36.5, which is molecular weight of HCl, is equal to 10.65 moles of HCl will be present per 1000 gram of water. So the solution is a 10.65 molal. Okay, molarity. So molality you can calculate. So moles. So these many moles, 10.65 moles of the HCl will be present in that water solution. Okay. In 100 gram of solution, now we want to calculate fractions of moles, right? Fractions of HCl in solution, mole fraction. So we have 100 grams of solution here. 28 gram is a HCl divided by 36.5 grams per mole. That is total 28 gram. Total we have 0.767 moles of HCl. Okay. So moles we have calculated out of 28% HCl is there, and how many moles are there in that 100 gram? For 100 gram, 0.767 moles of HCl. Now for 100 gram, we have 72 grams of water. 72 gram of water divided by molecular weight of water, 18 gram per mole, that is equal to 4 moles of water. So if you have 100 gram of solution, that 100 gram of solution contain 0.767 moles of HCl and 4 moles of water. Now what we want to calculate? We want to calculate mole fraction for HCl. So we have already seen the formula previously here. Mole fraction is equal to N2 divided by N1 plus N2 plus N3. In our case, HCl we have N2 and N1 plus N2. Only two fractions can be there because HCl is there and water is there. Just two components are there. So mole fraction of HCl is equal to N of HCl divided by N of HCl divided plus N of H2O. So here we calculate 0.767, that is N of HCl divided by this 0.767 plus 4, that is a 4.764. So mole fraction of HCl is a 0.161. Okay, so that is how we can calculate the mole fraction for the HCl. Okay, so that was mole fraction of HCl. So, concentration based on degree of saturation. Protein are often purified by differential precipitation with a neutral salt. Ammonium sulfate is the most common salt used for this purpose, although occasionally NaCl is also used. Okay, for precipitation of the protein, the sodium sulfate, ammonium sulfate is being used. So, concentration of ammonium sulfate used to salt out protein is always expressed in terms of percent saturation. Okay, so how much concentration of ammonium sulfate you will use, that is expressed in the percent saturation. So percent saturation is equal to concentration of salt in a solution as a percent of maximum concentration possible at the given temperature. So that is percent saturation. So concentration given temperature, how much salt can be present in the solution. In order to take into account volume changes that occur when large amount of salt is added to a aqueous solution, we need to know the specific volume of the salt. So here is a mu zero, mu specific volume is equal to volume occupied by 1 gram of the salt. So how much ml volume will be occupied by 1 gram of salt? That is a specific volume. Okay, that is a reciprocal of the density. So specific volume is a reciprocal of density. It is like if you jump into the water, how much volume you will take out, like that eureka is what you may be knowing. So that one. So specific volume, how much ml will be volume occupied by the 1 gram of the salt. Okay. So here we have one problem set is here. Specific volume of a solid sodium sulfate is a 0.565 ml per gram. Okay, so this much ml it will be occupied by 1 gram. The solubility of ammonium sulfate at the 0 degree Celsius is a 706 per 1000 gram of the water. Okay, so we have given the specific volume and we have given the solubility of ammonium sulfate. Now calculate the concentration of ammonium sulfate in a saturated solution at the 0 degree. So we want to calculate the concentration of ammonium sulfate in saturated solution at 0 degree. So saturated solution at 0 degree prepared by addition of 706 gram of ammonium sulfate to 1000 gram of water. So 1000 ml is there. We are adding 706, and you know that to each gram there is a increase of volume of a 0.565. So we multiply this 706 ammonium sulfate which we have added to 1000 gram of water, multiply it by 0.565 ml. So total, and for water already water volume is a 1000 gram, that is a 1000 ml. So this two calculation if you do 1000 ml plus this one, so it will be the 1399 ml will be this volume, total volume. Now the concentration of the ammonium sulfate in the solution we want to calculate. So how much ammonium sulfate is there in that solution? So this is the total solution volume. So this is 1399, and how much ammonium sulfate we have added? 706. 706 divided by 1399, that is 0.505 gram per ml. Okay, so that is the this much gram in this much ml. So you have already 706 gram per 1399 ml. So that is, if you do calculation, it is a 0.505 gram per ml. That is, if you want to convert it into liter, multiply by 1000 to our numerator and denominator, and you will get 505 grams per liter. So molecular weight of ammonium sulfate is 132.14. Therefore, molarity of solution is so how much is molarity? So you divide this quantity gram by weight divided by molecular weight is a molarity you can get. So 505 divided by 132.14 is equal to 3.82 molar. So that's this much molar sulfur concentration is there. So concentration we want in molar. So 3.82 molar solution. So this ammonium sulfate solution. Likewise, the amount of ammonium sulfate that must be added to 0 degree Celsius at 0 degree Celsius to 500 ml of 40% saturated solution to bring it to the 60% solution. Okay, so ammonium sulfate solution is there 40% and we want to bring it to the 60% and total volume of solution is 500 ml. So here is the calculation. So we can derive the simple equation giving the amount of solid ammonium sulfate that must be added to 1000 ml of the water at initial degree of saturation. So S1 is the initial saturation. S1 in order to bring the different degree of saturation S2. So already we have S1 saturation and S2 we want to bring. Knowing that 5.505 gram per ml is 100% saturation. That is one saturation. Okay. So S2 we can put it in this formula. S2 is equal to initial weight of ammonium sulfate present plus weight of ammonium sulfate added divided by volume, final volume in ml divided by multiplied by 0.505 gram per ml. So initial volume was 1000 ml. Okay, 1000 ml multiplied by initial weight is 0.505 gram per ml multiplied by S1 plus weight of in a gram divided by 1000 ml plus 0.565 and multiply it by 0.505 grams per ml. Okay. So if you put in this formula, you can get equation weight is equal weight in gram is equal to 505 S2, that is final concentration 60% minus S1 40%, this one divided by 1 minus 0.285 S2. Okay, so this equation you can use and put in this equation. Simply, if you use this equation, this is just how we derive it. If you are our problem is that we have 40% solution, we want to make it 60%. So this equation you will use. Okay, for this ammonium sulfate and this ammonium sulfate in here. Weight of ammonium sulfate added to the 1000 ml. S is the final concentration. S1 is the initial saturation. 505 gram of MSL per 1000 ml. That is 100% saturation. So 100% saturation you write here. Multiply by final concentration 0.6 minus zero point 0.4 divided by 1 minus 0.285 and multiply it by ES2. Okay, ES2 is a 0.6. So that is a 101 divided by 0.829. So that is 121.8 gram per liter. So 60.9 gram per 500 ml. So divided by 2, so you get 60.9 gram per 500 ml you need to add. So sometimes you have some concentrated, some solution. Why we are seeing this calculation? So sometimes you have this 40% solution, 40% solution, saturated solution, and you want to bring it to the 60% saturation. So in this case, so initial volume of present ammonium sulfate present plus weight added plus divided by final volume of solution multiplied by 0.505 gram per saturated volumes, right? How much it occupies. So if you do this, you will derive this equation, and from this equation, basically, you can directly add 60.9 gram to 500 ml of the 40% saturated ammonium sulfate, and then you will get 60% saturated ammonium sulfate solution. Okay, so this is important.